Hello and welcome to That's Just Wild with me, Steve Backshall.
Me, Lizzie Daly.
And me, Sarah Roberts.
The podcast all about nature, wildlife, and how I once had my ear hole licked clean by a Binturong.
Earhole. God, not the best tone for today.
This is a very special episode. We're coming to you today from Longleat. It's a place that's very dear to my own heart. I'm here doing wildlife shows. And although people come here for the exotic, for me, the best thing about here is the ancient woodlands, the native wildlife. You know that beavers have made their way back here?
I didn't know that.
Water voles and, very exciting, pine martens. No idea how they got here, but there are pine martens here at Longleat.
That's incredible.
It was you, wasn't it, Steve?
So what are we talking about today? What's our theme?
It's all about the colourful.
Colourful.
We're talking about bright colours
Yes.
in nature, flamboyance, extravagance.
Okay, love that. And we might even be meeting some of your wonderful animals in your show as well.
You may well do, yes.
Okay. Where to start, to be honest? I feel like there's so many different colours, so many different species. Sarah, I'm looking at you.
I was thinking about how we perceive colour.
Interesting.
Yeah. Well, if I can, I'd love to kind of give a little bit of a summary about colour vision, because I think how we see colour is actually an important part of the story. And we'll go into this in a bit more detail another time. But it's thought that in animals, around 500 million years ago, colour vision evolved. Around 350 million years ago, we saw that in our fruits. We started to see more colour in our food. That then went on to plants around 200 million years ago. And what's very cool is that about 150 million years ago, that's when we started to see the warning signals via colour. I can never say that word.
Aposematic.
Thank you for saving me there, Steve. And I'd like to go into that in a bit more detail. But aposematic coloration, and then that kind of evolved to see this big divergence of colour that we see in the animal kingdom for, sexual selection and for sexually selected traits and for those reasons. So in terms of like a timescale of colour, if you map it out like that, it's really fascinating how that's kind of changed over time. And now think about the vibrant colours that we get across a range of species. I want to go into blue in a bit more detail, but Steve, I know you've had so many experiences in the field with some of our most colourful birds, right?
Yeah, I mean, I think that dealing with colour, bright colours are very rarely a mistake. They're there for a reason. If an animal has bright colours, then it's either advertising something, and as you intimated, that could be that it's distasteful or that it's toxic. It could be a display, so an animal trying to attract another animal for mating purposes. It could be to intimidate another animal. And some of the most flamboyant animals, particularly when we're looking at birds, fish and mammals, tend to be the males. So it tends to be an element of sexual selection. There tends to be a grand, flamboyant display that's being put on to attract a female. And this is what's called an honest signal. So having super bright colours is a sign that you are fit to be an amazing progenitor of young. And I think probably the most extreme example of that would have to be the birds of paradise.
Yes.
The birds of paradise found in New Guinea, a couple in Australia and in the islands surrounding. And in those, the females are inevitably a downy kind of brown colour.
Dull.
Sort of dull. Yes, they are. Dull. And the males are the ultimate strutting superstars who just like, check me out. I am the business. One of them that I filmed, which is the one I think that is probably closest to my heart, because in some parts of New Guinea, they're comparatively common. You see them around a lot, and it's the superb bird of paradise. And this gorgeous bird, it's no bigger than, say, a blackbird here, but they have an extraordinary iridescent blue colour all the time, the males. And then when they come to a lek, which is like their stage, their dancing stage, and also I should say that some birds will actually pluck leaves from the forest canopy to create a beam of light, like a spotlight that falls down onto the branch where they dance, just like strutting
Literally
superstars.
setting the stage.
Literally setting the stage. And this superb bird of paradise spreads a head shield with this blue iridescent patch across it and jumps from side to side to create this absolutely alien display with a clicking sound going on all the time. And it is just to impress the females. The females will gather and they look on and you see them going, yeah, nah. and then going on to the
Believe
next
it.
one. Amazing.
Believe
I was
it.
going to ask though, are they compensating for something?
We're
Oh,
always compensating for something, Sarah.
It's a
Bring
long.
it
Why'd you look at me when you say that?
I just think it's just a long way to go, isn't it? To attract the female, it must take a lot of energy to produce those feathers to look that good. Do they lose out in any other way?
Well, so that is one of my favourite ideas in biology. To a certain extent, it's been a little bit questioned in recent years, but the handicap principle is one where you classically talk about the peacock's tail, but it would equally work for birds of paradise as well. And in the handicap principle, animals deliberately have something that disadvantages them to prove to the opposite sex that they must be the business. So with the peacock's tail, clearly having that giant mechanism of display makes it harder for them to take off, makes them more obvious to predators. It is a handicap to them, and that's the point.
Yeah.
It's the male saying, imagine how tough I am. Imagine how tough I have to be to carry this load of feathers around and still be here. I must be so tough, therefore pick me. So that is the kind of, in very, very basic, the handicap principle. And that is one of the reasons why you get so many vibrant, brightly coloured, particularly birds.
Yeah, Darwin actually wrote about peacocks to a colleague that they make him feel sick, because in the whole kind of trying to understand the handicap principle, it's like, how on earth have you gone that far? You've taken it too far with those feathers. But it's exactly that. It's that confidence and that investment of energy, which is just so brilliant. You spoke about so lovely there about that kind of blue iridescence, and I want to talk about blue because in the animal kingdom, the ability to produce blue is actually really rare. Have you guys heard about this at all as a colour?
I know it's really rare in the flower world, and I'll come back to that. But
Okay.
I didn't know so much about the animal kingdom.
Well, it's just interesting to think about how we actually produce colour. So it's kind of split into two kind of groups, if you like. The structural colour that you get in scales and in feathers and even in skin. So yesterday I was actually standing next to a cassowary, just looking at its bright blue ugly head. I love cassowaries, but I'm just like, how on earth?
Characterful head. Come on.
Yes, characterful head for a big old flightless bird. But it's just looking at that blue skin, you think, how is that produced? And structural colour is something that we see a lot in the animal kingdom. The other type of colour that you might have heard of is this ability to produce pigments through carotenoids. So it's pigment cells, essentially, that produces a lot of the reds and oranges and yellows that we see in the natural world. And then you also have the ability to produce melanin as well. So, if you see that bright blue hyacinth macaw, it's incredible. They have a lot of melanin. And as the light reflects against the structure of the feathers of that bird and is refracted back in our eyes, we see that big kind of vibrant blue. But to produce that pigment in vertebrates especially is so rare. It's never really seen. There's a few species, I think, that actually can do it. There's one species of butterfly called the olive wing that have been found to produce blue, but no one knows how. So it's just an incredible thing. And you see it in the birds of paradise as well.
You do? Yeah, the superb bird of
Yeah.
paradise has
Yeah.
an incredible iridescent blue shield. I wasn't going to do this at this point, but I have got an example that connects that connects rather well to our listeners who do not have vision. Right now, a gigantic snake has just entered the room. This is
Wow.
a Burmese python. His name is Monty
Not
Monty
any.
Python.
Hey,
Yeah,
I
I
see
know.
you did that.
And I've got the business
my
area here,
gosh.
the business end, so I can show you something really, really intriguing about blue in the natural world. Because, first of all, Lizzie, tell me about the colour of this snake here.
Okay, well, first, it's not what you imagine when you imagine the pattern of a python, that lovely kind of camouflaged, very blended in pattern of dark greens and browns. But actually, we've got a very yellow and white looking snake here.
Okay, and Sarah, because right now he is up close and personal to you.
You just want to get a bite on camera. I am going to be the first one that ever gets bitten by the Burmese python.
This is the chillest snake in the world.
That's
But
what they all say.
gaze into the eyes of Monty the Python and tell me what you see.
I was going to ask if he's blind. He looks like cloudy in the eye region. Is that right?
But his eyes are actually blue, right?
Yeah, they're kind of marbly blue.
Yeah. So if
like
this
that.
was a true albino snake, what would you expect?
Red.
Exactly. Yeah.
Yeah.
Because albinism is the complete absence of pigment, complete absence of melanin, as you were talking about there, Lizzie. But here you can see he's got stunning blue eyes. And the reason for that is that this is not an albino snake, not a true albino. In fact, it is what's called leucistic. And leucism is, I just can't say that word. I can't say it.
Leucistic is a bit of a tongue twister.
Yes. That is a lack of pigment, not a complete absence of it, but a lack of it. So you have these, as you said, yellow and white scales, and then there is still this blue colour to the eyes. And one of the most intriguing things about this is you get snakes like this in the pet trade, in the wildlife trade, all the time. They're super, super common because they're incredibly beautiful, but animals like this just don't exist in the wild. I mean, I've seen leucistic alligators in captivity that look exactly like this. They look like they're carved out of marble. But that wouldn't make it past hatchling stage in the wild because a whole array of predators would see it easily, pick it off, and just hammer it. So this gene in the wild is incredibly rare. In captivity, because these animals are being bred for it because they're so beautiful, they are everywhere.
Is it tactical?
So I have a question about that.
Yes.
Spitballing. But is it rare, or is it that just simply the ones that are leucistic or albinistic
Yes.
are just predated on? So do we...
That's exactly it,
Yeah,
though, isn't
does
it?
it
Surely.
reduce
So
the
they
number
don't
of
get to
them?
procreate, so they don't recreate the gene, so the gene itself becomes rare.
Fabulous, yeah.
But then it actually...
I feel like I'm sat on a massage chair right now. There's so much movement going on behind my back.
Yeah, I think he likes you, Sarah.
I mean, he can stay. It's quite comfortable, to be fair.
We actually, you mentioned iridescence there, but we do actually see iridescence in a lot of our reptiles, don't we? And in our inverts. And iridescence must be one of nature's best magic tricks.
Can you define iridescence for us?
Oh, that's a good question. It essentially means rainbow coloured. And again, when I was talking earlier about that, how we actually see light and why we really should be going into a bit more detail about vision, a lot of it is actually all about how that light is refracted back into our eyes. And so what you get with iridescence is like as you move around that animal or put it into kind of different angles and different light, you may see different colours or different strengths of that colour. And that's all down to do with the structure that I talked about, that structural coloration of the scales or the feathers and how it's been refracted back into our eyes. But it's beautiful.
It is quite common, particularly in snakes that have just shed their skin. And there are several species, the rainbow boa being a classic, but also the Amethystine Python, which is the biggest snake in Australia, sometimes known as the scrub python. And they can get up to be about 6 meters long. So at least as long, if not longer, than Monty Python here, but nothing like as big and heavy-bodied. And the reason they've got that amethystine name is amethyst. The amethyst is a precious stone that appears to have those rainbow colours within it, and the amethystine python has those, particularly just after it shed its skin, it just looks like it's kind of been rolling in oil. And you get these rainbow colours all the way down the length of them. I had the most amazing experience with an amethystine python at the beginning of this year, just a couple of months ago. So we were out looking for them at night in near the Daintree rainforest in Queensland. And I found one, super excited, got it all on camera and started heading back to the vehicles. And then we came across a huge amethystine python, at least as big as this snake that I've got here. So a good sort of 4 meters long, but something about it looked weird. It was right in the middle of the road and it had a massive, great big swelling around his head. And we realised that what had happened was it had been on a branch above us. It had grabbed a hold of a fruit bat, like a massive fruit bat, and had obviously started to try and eat it.
Yeah.
And then lost control of the branch and fallen. And it had fallen off the branch and plummeted down onto the road below. And it was kind of there with this massive bat in its mouth, like that. Wasn't willing to let go of the bat. He was like, no way, I've worked really hard for this. I'm not giving up on it. And so was in the process of trying to swallow this bat whole. The bat was still alive. And they both lying in the middle of the road, kind of like, you can't see me, right?
I'm a top predator.
Yeah, and we just literally lay down alongside it and filmed it
Wow.
while over about 20 minutes, it swallowed this bat whole. You could see a perfect bat shape in the middle of this amethystine python. And then it ever so slowly just slid away off the road.
Oh
Right, I'm
my
gonna have
God.
giant snake
More of that,
exit
please.
stage
Yeah.
left. Because
Quick question.
Sarah's
Do
massage
these-
is done.
Oh, that's such a shame. I thought I should have put more into that massage. chair.
Yes, that was quite
do they
good for
get
live animals.
sunburn?
Oh, that's a
Snakes.
superb question.
Well,
That's a really good
They've
question.
not got that much pigment, have they? And especially you were saying in Australia.
Oh, it's
I
in
mean,
leucistic snakes.
I don't know.
Wow. I haven't ever thought about it before, but the scales of snakes are keratinous, and I
Perhaps
would
not.
have thought that they probably don't, because our
Yeah.
fingernails and hair don't get burnt, right? This is
That's an
really
episode in
interesting.
itself.
Yeah.
So Lizzie, you talked about how rare that blue gene is. It's also rare in the plant world. It's actually the golden goose of the rose varieties. So I just want to talk about the plants because I absolutely love buying flowers. I don't know whether that was turning into my 30s, but suddenly it became like a real treat to treat myself to a bunch of flowers every now
Do
and
you
again.
buy your own flowers
Yeah,
for
I-
yourself? Do you
yeah,
buy other people's
I can
flowers?
buy
How are you
my own
owning up
flowers,
to that
Lizzie.
in public? Oh my
people
gosh.
buy flowers for you?
Not as
I mean,
much.
there's that.
You know, maybe I actually
Is this a
just
cry
placed
for
this
help?
here as a hint.
If you'd like to date Sarah,
Yeah,
call.
yeah, okay, yeah. No, but on a serious note, the flower trade has blown my mind.
Okay,
Like,
go on. Tell
Beyond
us.
the global flower trade is over 10 billion, and that's just cut flowers, right? So the UK, our trade is worth 1.3 billion pounds of cut flowers and ornamental plants. We love them. We want them. This comes at a cost because we don't really grow that many flowers in the UK. Most of these are grown around the equator because it's warmer, so you don't need to heat these greenhouses. And then, of course, they can do larger areas of land. They can pay their workers a bit less. And they can use any pesticides that they want to, and it's all going a bit downhill.
Does this make you feel even worse about the fact
look,
that
I
you are
had to
buying
look in the
flowers for
mirror.
yourself?
I told you I had to look in the mirror. It did make me feel pretty bad. Yeah, it did, because you don't necessarily realise even the carbon footprint. These flowers are shipped, most of them through the Netherlands. They take anywhere from 24 to 48 hours to fly from Colombia, from Israel. Most of ours come from Kenya. And so with that movement of flowers on a very, very large scale, besides the fact you also have all of those awful things that we talked about, sometimes you get passengers. So our affinity for having beautiful coloured flowers and to have all these beautiful greens and blues in lots of different areas also means that we are now getting really interesting invasive species all over the world, including the UK. So, for example, we have had lots and lots of different things, including a Colombian tree frog, which ended up in a bunch of roses in a Sheffield florist. And this is why we started looking into it, because one of the Cambridge Zoology Department professors got called in to identify this frog and thought it was a prank. Thought it can't possibly be what he thinks it is, but actually, yeah, it was.
All the way in Sheffield. Can I just address the fact that there's a certain smell in the room, and I feel like no one's addressed it?
I'm so sorry. I had a
I
curry
thought
last
it
night.
was Steve, yeah.
We can't keep doing this.
I would like to introduce our
is this?
next guest, because our next guest is called Biscuit. He is one of my favourite animals I've ever met.
I can
He's
smell
with
him from
Alid
here.
and Shona, who are two
Hello.
amazing folk.
Hey guys, oh
And
my
Biscuit
gosh.
is coming in to join us. So,
Biscuit. Hello.
do either of you know what kind of an animal Biscuit is, first of all?
Okay.
A bearcat.
I know they're called bearcats, but they're not related to either of those, are
That's
they?
quite right. And Biscuit loves a microphone. You got anything to
Hello.
say to us, Biscuit?
Biscuit, you stink. I don't
So-
mean to be rude, but
He smells
really
of
does.
popcorn. Is that right?
Exactly right. Yeah, absolutely. And now so does my house, and so do all of my
And your
clothes. Yeah, I mean he's so friendly. Right. So first of all, the bearcat name
Yeah.
is completely wrong. He's neither a bear nor a cat. He's actually in the viverrid group, which contains the genets and the civets.
yeah.
And the reason that I brought him on when we're talking about colour is because he is an arboreal species. That means he lives up in the treetops. And actually, could describe the kind of coloration of Biscuit the Binturong. What are you seeing?
He's got lovely little white highlights all up his arm.
Yeah.
So he's mostly black, but
Yeah.
actually when you look closely, he's got lots of kind of whitey grey hairs all over him.
Yeah.
So it's multitonal.
Multitonal. Good, strong description. I like it.
I mean, yeah, he's attractive. He's got a good fur coat. He's off. He's out of here.
Good camouflage,
He's out
Yeah,
of
but
my
he
team.
is also hanging around my neck with his prehensile tail.
Can
Look
we
at that.
just talk about that? A prehensile tail.
I mean,
that big is
Isn't it epic?
incredible.
I love the way it's just biting you continually.
I
That's
know.
my favourite part
It's like a
about
natural
Biscuit.
partnership going on
It's
here.
a love bite.
It's
Oh,
just
now
Steve's
I get to say like,
normal Wednesday.
yeah, I actually
I'm a
really
bit
do. I'll
jealous
take the
over
bite.
here.
Hi, darling. I don't know if he wants to say, oh yeah, hello.
You might have a
It's
little
love
nibble.
Bite. It's
Might
fine.
have a little
I'm
nibble.
quite, yeah.
Sarah, if you ever have children, I imagine this is what it'll
I
be
can
like.
add this to the list of weird things I've been bitten by, though.
So one of the next things I want to talk about when it comes to
Oh no!
is a
Oh no!
is a treat
Oh no!
for
end
all
of
our
the
YouTube
microphone.
viewers.
Oh, darling.
I want to talk a little bit about
Hi.
crypsis. So crypsis is the scientific name
really
for
liking the taste
camouflage,
of it.
Yeah.
for being able to match your environment. And quite often you find that animals that, for example, like Biscuit here, live in the rainforest canopy have very dark, blotchy colours because it's an incredibly dense environment.
How good is his eyesight, Steve?
It's pretty good. So he's nocturnal, so
He
he
kind
sees
of
pretty
reminds me
well.
of an eye with his eyes like that. Is that
absolutely.
right?
Yeah, absolutely. I mean, I would say that it's probably a bit of
can- you
convergent
can-
evolution
yeah.
going on. Exactly the same
Yeah.
thing. They're both arboreal animals, both mostly active by night, and so the eyesight is probably pretty similar. But the rainforest canopy is actually, despite the fact that it's closer to the sun, it's a really dark place. And so quite often you find animals that are very dark and blocky in colour, but sometimes you find animals that will actually mimic the light coming down through the branches and the trees. So a classic example would be something like a mangrove cat snake. So mangrove cat snakes are bright, barred yellow and black. You see them out in the open and they're incredibly obvious, but you see them up in the treetops and they're invisible. And the reason for that is that as light comes down through the leaves and the branches, it creates slats of light, slats which are very dark or very bright. And so this bright football scarf of an animal blends in beautifully to its background. And Biscuit here, despite the fact that he has quite dark, blocky coloration, actually they are almost impossible to see in the rainforest canopy.
I was going to ask, have you seen one in the wild before? Have you tried to film them?
I have seen one teeny tiny dot about 1 kilometre away
Really?
for no more than a matter of seconds. So coming here and seeing Biscuit, having him clamber all over me like this
Yeah.
every single day has been an absolute treat because you never get
Yeah.
to see one up close like this. And one extra thing, he's got this big blocky dark colours. There is one little bit of his face that shows up, and that's this little white stripe on his ears. And
Beautiful.
almost certainly that is going to be a signal to other binturongs. They very, very rarely get to meet other binturongs, and that tiny little splash of colour is going to be enough for them to pick a possible mate out in that dark,
Yeah.
crowded rainforest canopy.
It must be a balancing act then between not having too much colour that you yourself stand out to predators, but
Yeah.
having just enough that you can attract the perfect mate,
That's
right?
exactly right.
Well, it's
exactly
different,
right.
Different drivers, isn't it, really? And we forget that obviously we've talked about some incredible colours already, but sometimes just being dark and dull is equally as important when it comes to colour in the natural world.
Absolutely.
Can we just address the popcorn smell?
We
just
must.
quickly, because it
We must.
stinks. I mean,
Yeah.
I love it. It's wonderful, but why do they have
It's
such a
so
strong
distinctive,
smell?
isn't it?
Yeah.
It's down to something called the Maillard effect,
Okay.
which is the chemical reaction that you get when certain foods are cooking and browning. So, for example, freshly cooked bread or hot buttered popcorn, you get the expression of this one particular acid, acetylene pyrroline, and that's in their wee. And because of that, they have this incredibly strong popcorn smell.
He can wee on me anytime.
It's almost your
Can
catchphrase,
we
isn't it, Lizzie?
also address the fact that Biscuit seems quite peckish? Because he has been nibbling you the whole
He just loves a
That
little
is
nibble.
brilliant.
He
What an
does love a
amazing
nibble.
thing.
Yeah.
Met Biscuit. Go on a podcast recording.
As you were talking about eyesight and colour, how those two things connect,
Yeah.
it might be worth mentioning that crypsis, camouflage, is going to be different things to different animals depending on their eyesight. So as you intimated,
100%.
we have colour vision,
Yep.
but not all mammals do. And a lot of animals, particularly predators that are nocturnal, will absolutely not have colour vision because you can't have both extraordinary colour vision and really good low light vision. So quite a lot of predators, big cats particularly, may have dichromatic vision. They may kind of see in green and black and a little bit of white, for example.
Yes. Yeah.
And so quite often, well, there's a suggestion anyway that some prey species may have evolved to make best use of that. So, for example, the black and white stripes of a zebra that seems so obvious to us with our colour vision, maybe at periods impossible to tell apart when you've got a lion's vision.
Yeah.
A lion sees a whole bunch of zebras sprinting along together, and they don't see colour. They see
dazzle.
a blur because their eyesight has evolved really to be superb in low light.
Yeah, and just to kind of add on to that, to break down exactly what you talked about, that's dichromatic vision. So that really refers to having kind of two cone cells or photoreceptor cells. And then you've got trichromatic vision, which is what we've got. So it's the ability to see in red, green and blue wavelengths of light. And then you talked about kind of nocturnal life, and then also the world that we don't see, which is a whole nother thing, but the tetrachromatic vision. So that's birds see they have tetrachromatic vision, and that's where they see in shorter wavelengths of light and UV.
That leads in so beautifully to our next guests who are coming out to join us now. You can probably hear them already. Kieron and Ben, can you come on in? So guys, if you could, one of you come over here near Lizzie. And Ben, would you mind coming? Actually, yeah, you come in between us there.
Awesome.
So these are a pair of red-footed falcons. They're super, super noisy. And they sum up perfectly exactly what you were talking about, Lizzie.
Yeah, exactly. So I was talking about that tetrachromatic vision that a lot of birds have, that ability to also see in shorter wavelengths of light, so in UV, and that's just simply way above our pay grade as humans, and it has different purposes for different species. There was a really cool study looking at in puffins and their bills and how they actually glow under UV light. It's a bit more complex and a bit more nuanced than that, but that function to be able to see things like urine trails that you see in a lot of birds of prey like these falcons is really, really important. It allows them to hunt and be effective predators.
Yeah. So these two birds, they're not native to the UK, but we have them in Europe. They migrate from the right down at the bottom of Africa all the way up to Europe. And in some ways, they are quite similar to our own kestrel. They're slightly smaller. And being able to use UV light to perceive the urine trails of small mammal prey is incredibly important, because these, like our own kestrel, will hover. So they can use that motion of their wings to hold station, staring down to the ground, and being able to see a literal trail, a pathway along the ground where a vole has left stinky urine behind it, enables them to find prey that, could be buried in the grass, and then drop down and grab a hold of it. There's one other thing I have to talk about. First of all, I kind of need to describe our birds for anyone who is just listening to this, because you can hear them right now, but you can't see them. They're quite small. They're probably about half the sort of size of our own native kestrel, would you say?
Yeah, I'd say
About half the size. And they are very, very different in colour. Well, so the female here, can you describe our female for us, Sarah?
Colour-wise, she's like a beautiful auburn orangey brown colour, bit speckly. On her wings, kind of stripy with greys, a little bit of the orange kind of interlaced there. She's a very decorative bird, I would say.
And Lizzie, can you describe our male for us?
Our male's completely different. So he's completely covered in this lovely kind of charcoaly grey colour compared to the female, who's got that kind of brown patch on her head and on her front.
Yeah. So obviously when you've got a big difference like this between the male and the female, that's what we would call sexual dimorphism. And the male is so brilliantly coloured. He's almost gunmetal grey.
Yeah.
And also the red feet that give him his name really stand out against that. And you could argue that this is a case of what we were talking about earlier on, of the male being more vibrant, more flamboyant in colour, the female perhaps having slightly more crypsis, more camouflage, more ability to blend into her background. And they are both very, very noisy. They are full of character, and I absolutely adore them.
Incredible.
Yeah.
What an amazing thing to have with us.
It is also, you've got these two relatively small birds. To me, it blows my mind to think a bird of this size can migrate 10,000 kilometres. It can fly the entire length of Africa, fly over the Sahara Desert, over the Mediterranean Sea, over cities, over every single challenge you can think of. And it does that twice a year. It's just absolutely amazing. And that whole 10,000 kilometre journey could take 2 weeks.
2
Epic.
weeks.
Epic.
That is an epic migration.
Kieron,
Very lucky.
Ben,
Thank
thank you
you.
so
Thanks,
much.
guys.
Thanks,
Amazing.
you guys.
I just feel gutted that I don't know what she was trying to say to me. She was looking me square in the eyes.
I can tell you exactly what she was trying to say. She
Feed
was saying,
me.
feed me.
Feed
Feed me.
feed me
Feed me now.
But just quickly on that, because I teed this up thinking about that example of sexual dimorphism, which we see across the animal kingdom, but in species like puffins that I talked about, they both have these incredible kind of breeding bills that are very colourful to the naked eye. It just makes you think about that kind of how it's evolved and selected for.
I was going to say, if they both have them, then is it a sexual selection thing, or could there be like a whole other function that we just don't know for those glow-in-the-dark bills?
I'm really glad you asked that, because could it be multiple functions in the same way that iridescence on a beetle in a rainforest may also help with thermoregulation, because they're not really able to regulate well, are they, in that kind of environment, as well as blending in, as well as being able to, I don't know, attract a mate. It could be a variety of functions.
Steve, I am right in thinking, though, that puffins and all of these birds that we're just seeing related to dinosaurs birds.
They are a dinosaur.
Could the dinosaurs also have had some glow-in-the-dark features that we don't know about?
It's an intriguing question, and there is some amazing science which is starting to break down the colours in the dinosaurs that we know had feathers. So, we know that certain groups of dinosaurs would certainly have had a degree of feathering. They could have been completely covered, as much as the two little falcons that we've just had pretty much standing on your shoulder. And it kind of stands to reason that they would have been colourful. We know from what we call phylogenetic bracketing that so many other things that our modern birds have, the dinosaurs also had. Quite a lot of paleontologists will refer to dinosaurs, non-avian dinosaurs and avian dinosaurs, so placing them so closely related together. But that was always just kind of like an idea. People were always kind of like, well, maybe they had amazing bright colours like a peacock or a bird of paradise. Until in 2010, some remarkable research started showing within the feathers of fossilised dinosaurs tiny structures which are called melanosomes. And the shape of these structures, which is kind of almost bean-like microscopic structures within the feathers, we've shown from modern birds, it relates to colour. So there are particular melanosomes that express for black, for white, for orangey and ginger and brown colours. So we know that certain dinosaurs, for example, Anchiornis, possibly Archaeopteryx, things like Sinosauropteryx, all had Chordopteryx coloured feathers. And most of them we've been able to distinguish were gingery, black, white, and had very, very similar kinds of, for example, bands across their tails as a modern Harris's hawk does. Which just blows my mind. And surely, we're looking at a lot of predatory dinosaurs probably having a degree of crypsis or camouflage. There is no reason why there would not have been some dinosaurs that wouldn't have had brilliant colours for display. Why not?
It's those pigment cells that we were talking about earlier. And I'd imagine in the process of fossilization, you might be able to find some melanosomes in skins or feathers or whatever it may be, but it'd be a lot harder to be able to do that in pigment cells like you get in lots of our marine life.
Did any of you lot see Prehistoric Planet?
Yeah.
Probably my favourite sequence in that was the Carnotaurus sequence. Do you remember that?
No,
so
I don't.
Carnotaurus is sometimes known as
and you don't know,
the bull of the late Cretaceous. It's this wonderful looking predatory dinosaur with two big horns either side of its head like that. And they have teeny tiny forelimbs. So you think of a Tyrannosaurus as having tiny forelimbs. These are like itty bitty little sticks, clearly no use whatsoever for any method of feeding for predation. But scientists have hypothesized that because they have a really mobile joint at the base of those tiny stick-like arms, that they could have been rotated. And they came up with this wonderful visual in Prehistoric Planet where the Carnotaurus has bright colours and, like a bird of paradise, leks for the females. So the male spins around these tiny little arms, showing off his beautiful, bright coloured underside of his arms and chest, just like a modern bird of paradise does at a lek to attract a female. And you could
this basically like a T-Rex style dinosaur was dancing around on a jazzy stage.
Yeah.
Okay, so
With nipple
hold
tassels.
that thought.
Yes.
You've got dancing, jazzy dinosaurs.
Yeah.
On their legs.
She's doing the jazz hands while we're doing it.
I
I love it.
Shimmering. Okay. And this is just like Jurassic Park that never got made. But in the sky, as they're jazzing around, you have beautiful bouncing colours that we've seen a lot last year.
Dun, 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 dun.
Dun, 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 dun. What are they, Lizzie?
The Aurora Borealis.
Yeah, but
The
have you heard of
amazing-
Steve?
Huh? Well, yeah.
Ha ha!
He's with us.
Okay, yeah. So we have multiple colours in our sky that we are now seeing a lot more of at this moment in time because the sun is having a bit of a stage. Every 11
moment.
years it gets, a little bit sassy and we
Jazzy.
get Aurora Bora. And
Aurora Bora?
Aurora
Aurora
Borealis.
Can we also
and
just think
we are
maybe, like, it's the
getting
Northern
the
Lights?
Northern Lights. We are able to see them quite clearly in
Yeah.
lots of places that we couldn't before. And because of that, I had no idea. You get storm chasers that go and chase tornadoes. I've since learned that you also get Northern Light chasers. Or
I am
Aurora
one.
Chasers. Of
I am
course
one.
you are. Of course you are.
I have
Steve.
3 of the apps on my phone, and I
Hey.
have travelled to various places specifically to see the aurora, including my back garden not far from London, where I
Hey.
got the pinkest and reddest aurora
Oh.
I've ever seen. I spent a lot of time in the Arctic Circle,
That's
and
cool.
the pinkest, reddest aurora I've ever seen was in my back garden.
That's cool.
So-
can I try and one up you because you are Steve Backshall, but I'm
Go
going
on.
to try. I've seen them from the plane on the way to the Arctic. That's pretty cool, isn't it?
That's
I was like
epic.
whipping up the window and then there they are. Sent a picture home. I was like, because there's a bit of a running theme in my family that my mum has always wanted to see the Northern Lights. She's seen them now. But I was just
You were just
casually
being
snapping
really
them. I'm
smug
like,
daughter,
just a
like-
Tuesday flight, Aurora.
Oh my gosh. Right. Okay. So obviously we have lots of different colours on the aurora, which of course is the greens and the blues and the reds. But our aurora chasers had discovered through citizen science, I love this, something that they termed Steve. You've got these aurora chasers that have found this phenomenon that nobody's really paid much attention to, that is sometimes happening at the same time as an aurora, but it's not the aurora, it's just a completely different thing that's its own colour. In terms of colour, I think it's a lilac, so it's on its own. It's happening at the same time, and they've identified it as separate, and they bring it to NASA scientists in the pub after they've done a talk, and they present it to them, and they're like, all right. They named it Steve.
After me?
No, not after you, I'm afraid.
Can we pretend they are?
Have you seen the film Over the Hedge? It's like a kid's film. You've got kids, you might have seen it. It's a kid's film, and they discover a new hedge, and rather than be scared of the new hedge, they name it Steve because Steve's not an intimidating name. So they named this thing Steve, but basically, they brought this evidence. It's now strong thermal emission velocity enhancement. We're not the only planet that has it, but you have to have a lot of conditions in the right place to get it.
Love it.
But
Love
yeah,
it. Right.
yeah,
Absolutely
beautiful.
brilliant. Now, I guess one thing we haven't really talked about is not the liars of the animal kingdom, but those who found cheeky little ways using colour to evade predators or to kind of showcase toxicity, and that's through mimicry, right?
Fur coat, no knickers, basically.
Essentially, not that kind of podcast, but it's exactly it, Sarah. It's exactly. Sorry, Steve. You're stuck between a
quite
silly
shocked.
sandwich right now. So I just quickly, because I filmed with them recently and I thought they were absolutely incredible, found in the UK, ladybird spiders. Steve, have you filmed with them before?
Oh, they are really cool looking
love
things.
ladybird
They're
spiders.
so awesome. So yeah, there was in the 1980s, they were thought to be extinct in the UK, and then in the 1980s there were 7 individuals found in Dorset, and now there's a guy called Ian Hughes that's helping restore populations around the UK. But for those who are listening, if you were to look at a picture of a ladybird spider, the males have this incredible crimson red abdomen and the dots of a ladybird, and the females are lovely and blue and velvety, and they're much larger than the males. But that ladybird appearance is because ladybirds are thought to have that kind of bitter taste and toxicity. So they do an incredible job, and now really cool project, but they're being brought back to the UK in healthy numbers.
Mimicry in colour is utterly fascinating.
I know.
Probably the best known of the mimics would be the coral snakes and the various mimics of those, which are found in the New World. So essentially you've got a coral snake, which is highly venomous and has bright colours, bands of red, black, yellow, sometimes white. And other animals learn that you don't mess with a coral snake. Therefore, other snakes, colubrids, not even closely related, have over deep time taken on those same colours, and the animals that are avoiding the coral snakes will also avoid them. That's classic Batesian mimicry, and it's a really good way of, without having to invest in the energy you need to make venom, you still gain the protection from looking like another animal that is venomous. There's another closely related kind of mimicry called Mullerian mimicry, where you have two species, both of which are likely to be distasteful. It's quite often in butterflies, and they both gain an advantage because essentially there are lots and lots of other animals learning that you don't chew into an orange, black and white butterfly because it's going to taste bad. So mimicry is something which has spread through the natural world, and it's sneaky. It is just a sneaky way of gaining an advantage without having to invest the actual energy in doing something.
Love it. Right, that's it. That's all we've got time for. A massive thank you to Longleat for having us and for meeting the incredible animals today, and to all the wonderful keepers here as well. Remember, you'll have a Q&A episode coming your way very soon. Please send us in your questions to questions@that'sjustwild.com and we will get to them.
We are a new show, so any support is really, really welcome. You can follow us on your favourite podcast app. Leave us a review, it makes all the difference. And for ad-free listening, our newsletter, special deep dive episodes and members-only benefits, you can subscribe to us at that'sjustwild.com. That's that'sjustwild.com. And remember, we're on YouTube, TikTok, Instagram, Facebook, and you can find us at That's Just Wild Pod.
Woo! Thanks for listening.